and we find the area of the rhombuses and the kites. But before talking about how can we find the area of them, let's talk about the difference between these two shapes, the rhombus and the kite. Look at the first one here. For the rhombus, all the sides are congruent and are equal. What does it mean? That's mean if I have this side, these are now the rhombus. For the rhombus here, all the sides are congruent and they are the same. They have the same length. If it is here 5, here it will be 5, here it will be 5, and here it will be 5. For this shape here, it's like a square, but the square, all the angles are right angles, but in the rhombus, it's not right angles. It will be an acute or obtuse angles. So this is for the rhombus. All the sides are congruent, all the sides are equal. This shape, we call it rhombus. Now, the side that's connect between these two parallel angles, we called it diagonal one, and the side that's connect, or the line segments that connect between these two opposite angles, we called it diagonal 2. And these two diagonals are perpendicular on each other. So because of that, we know, if you know now the length of the first diagonal, if you know the length of the second diagonal, the area, it will be half So it will be half the product of the first diagonal times the second diagonal. So if you know the length of each diagonal, multiply it by half, you will find the area of the rhombus. Now what about the kite? In the kite here, it has the same shape, but each, these two sides, it's like making like two isosceles triangle. These two sides are equal, and congruent too, and these two sides are congruent too. It's made from two isosceles triangles connecting each other at a common side. Now, the segment that connects between these two opposite angles, we call it diagonal 1, and another line segment that is perpendicular on the diagonal 1, we called it diagonal 2. And the area the area here also for the kite, it will be half the product of diagonal 1 times diagonal 2. This is how to find the area of the rhombus and the kite. It is half the product of the length of its diagonals. Now, in this question here, he asked me now to find the area of a kite with the diagonals that are 12 and 9. Here he told me that the diagonals are 12 and 9. Where is Sausan? Here we have many absents. Habiba.
Yeah, we are 8.
Yeah.
She has a problem with her connection.
It's okay. Now, so because of that, I need now to find the area of a kite with diagonal 12 and 9-inch long. So here now we have this kite here. He told me now that.
Teacher, are you typing?
Yes.
Oh, no, it's okay. Yeah, no, it's okay.
Then the first diagonal is, the smallest one is 9, and the longest one here is 12. So because of that, I would say now this is 12 and this is 9. I need now to find the area of the kite. We know that the area of a kite is half the product of the first diagonal times the second diagonal. Now, the length of the first diagonal is 12 times the length of the second diagonal, it is 9. So it will be 54-inch squared. This will be the area of the diagonal, half D1, D2.
Teacher, like the diagonal one is always small?
No.
Or
Diagonal
no?
1 is 12. Diagonal. I told you that according to my shape here, the diagonal, the longest diagonal is 12, and the smallest would be 9.
Oh, okay, so it doesn't matter if it's
No.
two or
They are
diagonal one.
product. If you change the order, it doesn't matter. No. Now, let's do problem 3, but I solved the got it because it's easier than the problem. Now, let's do problem 3. In this problem here, he told me now that K, the shape of the kite KLMN, has it's a kite. I need now to find the area. Now, let's draw it here now. For this one here, as we see, now, for this one here, he told you that this one is 2. And this one, he told me now it is 5. And he told me also that this one is 2.
I'm so sorry, teacher. My cat caught a bird and I had to clean.
Okay, so there's no problem. Then here we have this one. This is
Where teacher? Yeah.
Are you writing on the screen?
yes.
There is nothing.
I can see it.
Did you see my writing? My drawing here?
I see it.
I can see it. It's just the question.
I think it will appear by a little time.
I can see your writing.
Teacher, it will take a little time to see it.
Maybe because of your internet connection. Wait a few seconds, it will appear, inshallah. So look at this kite here. In this kite here, as you see, the diagonal here, they are.
But teacher, it is not 2, it is 3.
Sorry. Yes, thank you. Here it's 3. So now here we say that this is a kite. I need now to find the area of the kite. So the area of the kite is half the first diagonal times the second diagonal. Here is half. What is the length of the first diagonal? It is 2.
Add 2 by 5.
7.
Plus 5. So it will be 7. And the second diagonal, which is this one, the 3 plus 3, which is 6. So because of that, I will say now that the area is 21 meter squared. I multiply 7 by 3, and you get 21 meters squared. Now, since I told you that in a kite, I told you like it's a two, wait, give me 1 minute, please. I told you now it's a two isosceles triangle because here we have these two sides are congruent. So because of that, any bisector comes from the vertex in the isosceles triangle and perpendicular on the base will cut the diagonal into two equal halves. That's why here is a 3 and here is a 3. So later on, if I told you the length of this half of this diagonal, the second one, it will be by default a 3. Is it clear why?
Yes.
In the
Yes.
in the isosceles triangle, because they are isosceles, that means these two sides are equal. So any bisector that comes perpendicular on the base, okay, will make this these two sides are equal. That's why if I told you here is a 3, the second one here it will be 3 too. That's why here we have 3 and 3. This is in kites. Now, let's talk now about the area of the rhombus. The area of the rhombus is as the same as the area of the kite. It's half first diagonal times the second diagonal. In this one here, he told me that the length of, before that, we said before that the rhombus, all the sides are congruent and unequal. This is for the rhombus. And it's different than the square, that the square, it's all the sides are right angles, but in the rhombus, it's not right. It could be obtuse or acute. So if this side here is 6.5, so that means all the sides are 6.5. And since, as we said in the kite, these two sides are congruent, so that means it makes an isosceles triangle. So, which means that it makes the length of this diagonal equal in the half of the diagonal here will equal the second half. So, because of that, if here is 2.5, here it will be 2.5. It is as the same as the kite. But also, if you go back here, wait please. If you go back here to the kite, here now, yeah. If you go back here to the kite, we say that all these two halves are equal, but for the second diagonal, they are not equal. So in the kite, only two sides on one diagonal are equal. In the rhombus, no. In the rhombus here,
all the sides are equal.
This one and this one are equal. The half of the half of the first diagonal are congruent with the half of the second diagonal, and also the half of the longer diagonal is equal the half of the second half of the longer diagonal. That's mean if here is 2.5, here it will be 2.5. If you have this rhombus here, and for this rhombus, all the sides are equal, 6, 6, 6, 6 as an example, and also if this one is 8 and this one is 10, the big one is 10 and the small one is 8. So because of that, and I told you that it connects between they are isosceles. So because of that, it's this the longest diagonal. It cut the diagonal one with 2 equal halves, so it makes them 4, 4. And the second diagonal, it cuts also the first diagonal, it makes them 5 and 5. This is for the rhombus. The diagonal here, they are 4, 4, up, 5, 5, 5, and 5. But in the kite, it's not. It's okay, it make here 2 and 2, but up it will be 6 and down it will be 8. They are not equal. Is it clear?
Yes.
Can you repeat it again?
Okay, for the rhombus and the kite, I told you for the rhombus, all the sides are equal. And the diagonals inside it here, they have the same, they mean that they are cut into 2 equal halves. So the first diagonal, it cut the second diagonal into 2 equal halves. It makes them 4 and 4. And the second diagonal, it cuts the first diagonal into 2 equal halves. It makes them 5 and 5. This is for the rhombus. For the kite, it's no. For the kite here, the big diagonal or the longest diagonal only cut them into 2 equal halves. Only one diagonal can cut the second one. But in the rhombus, the 2 diagonals cut each other and make them equal.
Okay,
Or like bisects them, you can say. If this is like, it will be equal, so it bisects them, it cuts them also into 2 equal halves. But for the kite here, okay, it doesn't cut them because they are not isosceles. They are not bisector. This line segment is not bisector. So it didn't cut these 2 triangles into 2 equal sides.
Yeah, okay,
Now,
thank you.
you're welcome. So because of that, in the rhombus, if I told you, if here is 2.5, you will tell me by default, it will be 2.5. And also, if I told you, if here is 4 as an example, down, it will be 4. Why? Because this is a bisector. This bisector, it cuts the isosceles triangle into 2 equal halves. That's why it makes it 4 and 4. Now back to my question here. In this question, I need, if I want to find the area of the diagonal, I need 2 things. I need the first diagonal and the second diagonal. The first diagonal, it's given, it is 5. Now what about the second diagonal? How can I find it? I want you now to look at this triangle here. For this triangle, here we have 2.5 and here we have 6.5. Is it right?
Yes.
So I need now to find x. How can I find x?
By the Pythagorean theorem.
Pythagorean theorem. So 6.5 squared equal 2.5 squared plus x squared. 6.5 squared minus 2.5 squared, it is 36. So x is 6. What does it mean? That means, let's go back to our triangle here. So since now this side,
Each one has 3.
no, if here is 6, here it will be 6 also. Because by this triangle, we found that it is 6, as we found it down here. So if here is 6, the second diagonal, it will be 6. This is only in rhombus. I repeat why, because this white is a bisector that's in the isosceles triangle, and there's a theorem saying that if there's a bisector, it comes from the vertex of in the isosceles triangle, it cuts the base into two equal halves. So if this half is 6, the second half will be 6 too. So the second diagonal here is 6 plus 6, which is 12. Then after simplify it, you will find that the area of the rhombus is 30 feet squared. Is it clear?
Yes, teacher.
So the conclusion here for the rhombus and for the kite. This is a kite. And this is the rhombus. In this one here, we have a diagonal. And here also we have a diagonal 1. And we have here a second diagonal, diagonal 2, and here we have diagonal sub 2 also. Now, this is kite, and this is rhombuses, or rhombus and kite. For the kite here, these two sides are congruent, and these two sides are congruent. In the rhombus, all the sides are congruent. And also, this half is equal to this half. The half of the diagonal here is equal to the second one. Let's make it with 3 dashes now. Only one diagonal can, only one bisector can cut the diagonal. In the rhombus here, we have these two halves are equal, and these two halves are equal too. So if I told you here is 3, here it will be 3. If I told you here is 4, here it will be 4. In the kite, if I told you here is 2, you have to tell me it is 2. But if I told you here is 5, you don't know anything about this half. Is it clear?
Yes.
Yes.
Now let's talk about this gutted here. In this gutted, a rhombus has sides 10. If the long diagonal is 16, what is the area of the rhombus? So here now, you have this rhombus as you see here. Now, for this rhombus here, we have the sides are 10. So that's mean all the sides are equal. And the long diagonal is 16. This red one, it is 16. So to find now, he asked me now to find the area of the rhombus. And to find now the area of the rhombus, I need to find the second diagonal. To find now the second diagonal, as you see from here, I will make a bisector that's cut it into two equal halves. This bisectors, the length of these bisectors will make a diagonal. So this bisector, it cut the 16 into 8 and 8. Now, if you look at this triangle here, if here is 10 and here is 8, who can tell me what is the length of this side? Using the common triangles I told you about them.
3.
It is what? It is 6. It will be 6. The answer will be 6. How can I find it? By using the Pythagorean theorem. 10 squared is equal x squared plus 8 squared. So 100 minus 64 is equal x squared. So x squared is equal 36. So x is 6. That's why here now it will be 6. Now, and I told you in the rhombus, if this one is 6, what will be the length of this bisector here?
It will be also 6.
It will be also 6. Now after that, I have the length of the diagonals, so I can find the area of the kite. So, the area of the rhombus. So the area of the rhombus here is half d1 times d2. What is the length of the first diagonal? It is 16, which is 8 plus 8. And the second diagonal
12.
will be 6 plus 6, which is 12. Then let's simplify them. 8 by 12. 8 by 10 is 80. 80 plus times 12 is 16.
96.
It will be 96. So the area here is 96 centimeters
Squared.
Centimeter squared.
Yes. Now let's talk about this one here.
Teacher, I think there's a question we didn't complete it. The last class. Yeah.
I solved everything. Just multiply the numbers.
Oh, okay.
In number 25 here, we have wait, let's read the question first. In number 25, find the area of each rhombus. So this is a rhombus. And for the rest of here, the diagonal here is 6, and the length of each sides are 5, 5, 5, 5. Why I say they are 5? Because it's a rhombus. Now, it is 6. So if there's a line segments that comes from them, it cut the diagonal, because I told you in the rhombus, each diagonals cut each other or bisects each other. So if it's cut it, here it will be 3, and here it will be 3. Then for this triangle here, as you see, in this triangle, here we have 5, here we have 3, and here we have x, which I don't know the value of it. To find it, we can use the common triangles that I told you about them, or you can use Pythagorean theorem. So 5 squared, it will be 3 squared plus x squared. So 25 minus 9 is equal x squared. So x, it will be 4. So because of that, if here is 4, here it will
So
be
the other side is 4.
This happen only in the rhombus. If it's kite, it cannot happen. So what is the area now? It will be half d1, d2. Yes, Habiba. What is the length of the first diagonal?
It's 8.
8, thank you. And the second one?
6.
It is 6, thank you. Then after simplifying, the answer, it will be 24 meter squared. This is for the area of this rhombus. Now this one here, number 37.
Ahmed, I want to write the answer. Yes, okay, this is fine.
In number 37 here, we have this. Wait, the question here is also to find the area of the rhombus. So there's a rhombus here. For this rhombus, we have them like this. And he told me now that the length of this half here is 3. And the length of this angle here is 45. I want now to find the area of this rhombus. Since it is a rhombus and this half
So
is
the other side is
the
a
other half, it will be 3 too. Then, if you look at this triangle here,
It is a right triangle, so we can use the tan to solve.
yes,
And which it is 45, 90, right? The 45, 90 triangle.
the second one you mean here,
This
Yeah.
is a special case. To
It is
get
a
the other sides multiplied by square root of 2. Multiply the short like by square root of 2.
yes, it's derived from the tan. Now, because from the cosine, because cosine 45 and sine of the 45 also, it is 1 over square root of 2. Now, for this triangle here, as I told you, in the kite, in the rhombus, here we have an isosceles. So this bisector, if it is cut them into 2 equal halves, so it's equal. Let's make this triangle, or all the triangles here are right triangles. If here is 90 and here is 45, and this is 103, I need to find x. Let's say I need now tan 45. Now the tan 45, it is opposite over adjacent.
Adjacent.
Now
Which
tan
is
45, the tan of 45, as you know, it is sine 45 and over cosine. And the tan 45, it's 1, because the sine and the cosine are equal. So tan 45 is equal to 1. Then what is the opposite here?
it's a 3.
3
3
And
over
the
x.
adjacent.
over x.
So x it will be 3, 2.
3.
So because of that, I will say up is 3 and down it will be 3, 2. Then what is the area of the diagonal will be? Half d1
times 6.
d1. So what is the length of the first diagonal? It is 6. And the second
Times
one
6.
will be 6 too. So after simplifying them, you will have 3 times 6, which is 18 centimeter squared. Is it clear?
Yes, teacher, thank you.
Yes. Yes.
Maya, do you have any question?
No, teacher.